Write down first problem. For the subspace law, for the subspace H is equal to set of S minus 2t, S plus t, 3t, such that S comma t in R, find a basis and the dimension. Find a basis and the dimension. Find a basis and the dimension. So now you have to solve this. First you have to discuss what is the meaning of basis. What is the meaning of basis? You write as basis is compulsory, all linear independent and linear span. And next, dimension. What is the meaning of dimension? Dimension is nothing but number of bases. Number of bases is called as a dimension. So three points you have. First point is linear independent, linear span and number of bases. These 3 points you have solved, the problem is completed. Okay. So now these 3 points. So first you have to find out what is the linear span. So first you take here the given H is equal to set of S minus 2t, S plus t, 3t, such that S comma t in R real numbers, right? So you write as here, you take the common for S in the column way. S coefficient is here 1, here S coefficient is 1, here there is no S, 0. Plus again here t variable common. What is the t coefficient here? Minus 2. Here t coefficient is 1, here t coefficient is 3. Such that here given S comma t in R. Right? So now what do you write in this? S into V1 bar plus t into V2 bar. That is nothing but you write as set of S into V1 bar plus t into V2 bar, such that S comma t R belongs to real numbers. So what is the where V1 V2? You write as where V1 bar is equal to, write as a vector 1 1 0 and V2 bar vector is equal to, write as minus 2 1 3, right? So this is a V1 bar and V2 bar. So what do you write now? This is called as linear combination of the two vectors. This is called as linear combination of the two vectors. What are the vectors? Linear combination of V1 bar comma V2 bar. V1 bar comma V2 bar. So that is equal to, write as span set of V1 bar comma V2 bar. Span set. What do you write? H is equal to span of two vectors. Is it right? Span of two vectors. Once you completed a span vectors, those span vectors are linear independent or not, you have to verify. Those span vectors are linear independent or not, you have to verify. What is the meaning of linear independent? The independent means you have if you take a set of two vectors, that two vectors must be a scalars are equal to 0. Right? If you write a linear combination, that linear combination can be written as C1 into V1 bar plus C2 into V2 bar is equal to 0 bar. Right? So once you write that equation, you have to find C1 and C2. Once you get the C1 and C2 values, the C1 and C2 are equal to 0, therefore it is called as linear independent. That is one of the definition. Other than that definition, for example, if you take two vectors, consider two vectors. What is the considered two vector? I will write as V1 bar is equal to k into V2 bar, a set of two vectors. V1 bar is equal to write as 1, 1, 0, that is equal to k into V2 bar is equal to minus 2 and 1 and 3. Right? So what is the solution in this? For example, minus 2k is equal to 1. That is here minus 2 into k, minus 2k is equal to 1. First row and first element. Then again, second row is what? If you write as k is equal to what you write in this equation? That is k is equal to minus 1 by 2. K is equal to minus 1 by 2. And the second one here, k into 1, k is equal to here 1. Already you will get. Then next third one, 3k is equal to 0. Therefore, k is equal to 0. Right? Now implies there are the three solutions. One is the k is equal to minus 1 by 2. Another solution is k is equal to 1. And another solution is k is equal to 0. These 3 points you substitute here, you will get both are equal. Verify. Both are equal. You have to verify. If you equal, therefore it is called as a linearly dependent. Suppose what I write, suppose the consider V1 bar is equal to k into V2 bar is a linearly dependent. If you not equal, therefore it is called as a linearly independent. So if k is equal to minus 1 by 2, the both are same. Observe this. Verify here. Minus 1 by 2 into minus 2. Minus minus cancel, 1 by 2 and 1 is okay. Then next here minus 1 by 2 here is equal to 1. Is it possible? No. Therefore 3 by 2, 3 minus 3 by 2 is equal to 0 is possible? No. It is not equal, right? So the same condition k is equal to 1, minus 2 is equal to 1. Is it possible? No. Here minus 1 is equal to 1. Is possible? No. Then again 3k, that is 3 into 1, 3 equal to 0? No possible. Then again same k is equal to 0. This is total 0 vector. The 0 vector is equal to this vector? Not possible. So this is the reason for it is not multiple of each other. Write down. Up to right here. Up to right here. The given set of vectors, V1 bar and V2 bar, not multiple of each other, therefore the set of V1 bar and V2 bar are linearly independent. Therefore, H is form a basis for R power 2. H is form a basis for R power 2. Hence, dimension of H is equal to how many bases? 2. Dimension of H is equal to 2. Is it clear? What do you do here? First, you take a common for S, you take a common for T, you write a linear combination. That linear combination is you write as SC into V1 bar plus T into V2 bar. Then is equal to linear combination of two vectors V1 bar and V2 bar. Once the set of linear combination is called as a linear span, the span of the two vectors. When the span of the two vectors is satisfied, then go for consider for the vector positions. That vector positions are we consider for V1 bar is equal to k into V2 bar. That means one vector is equal to scalar multiple of the other vector, therefore it is called as a linearly dependent. If not possible, therefore it is a linear independent, right? So it is not possible. You observe that we are not possible. That is not multiple of each other. So therefore it is a linear independent. Once linear independence and linear span is completed, therefore it is called as a basis, right? Once it is a basis, how many bases in a set? You write as a dimension. Okay, so these are the 3 points. One is the linear span, linear independent, and basis and dimension. Okay, 3 points. So that 3 points, once you completed, you write the direct dimension value. Okay, right. Take another question in the same another problem. For the subspace H is equal to, for the subspace H is equal to, for the subspace H is equal to A minus 4B minus 2C, A minus 4B minus 2C, 2A plus 5B, 2A plus 5B minus 4C, minus 4C, and minus A plus 2C, minus A plus 2C, minus 3A plus 7B plus 6C, 6C, such that A, B, C belongs to R, belongs to R. Find the dimension and form a basis. Find a basis and a dimension. Form a basis and find the dimension. Find a basis and dimension. So same, simple problem, same problem. In the previous one is 2 vectors, here given is the 3 vectors. Why? A, B, C are there, right? So we will take for H is equal to direct common. I will take a common for A. Write that. What are the coefficients? 1, 2, minus 1, minus 3. What is the B coefficients again? Minus 4, 5, 0, 7. Then next C coefficients. Minus 2, minus 4, 2, 6. Such that A, B, C belongs to real numbers. Right? So now, what is the combination now? A into V1 bar plus B into V2 bar plus C into V3 bar. So what do you write? H is equal now? I'll write just A into V1 bar plus B into V2 bar plus C into V3 bar. Right? So you can write as here such that A, B, C, R belongs to real numbers. Is it clear? After that, you write here how many combinations? Linear combination of which vectors? Which vectors? V1 bar, V2 bar, and V3 bar. V3 bar. Right? So it can be written as span set of V1 bar, V2 bar, V3 bar. Right? Span vectors. Once you get the span vectors, you write H is equal to span that is span of vectors. Write that vectors 1, 2, minus 1, minus 3, minus 4, 5, 0, 7. Then next minus 2, minus 4, 2, 6. That's it. Okay, these are the span vectors. Once you get the span vectors, so now next to go for the combinations. Right? So now in these combinations, now consider the equation, right? What is the consider the equation? Consider the linear combination of the vectors, of the equation is A into V1 bar plus B into V2 bar plus C into V3 bar is equal to 0 bar. This is a linear combination equation. So once you get this equation, A into again, write 1, 2, minus 1, minus 3 plus B into write as minus 4, 5, 0, 7 plus C into write as minus 2, minus 4, 2, 6. Right? This is equal to how many rows are there? 4 rows. How many zeros you write? 4 zeros. The number of rows is equal to the number of equations. Right? So now you write as here equations. What are the equations? A into 1, A, minus 4 into B, minus 4B, minus 2C is equal to 0. First equation that we consider already is given, right? That is 1. Next equation, 2A plus 5B minus 4C is equal to 0. This is number 2 equation. Number 3 equation, minus A plus 0 into B plus 2C is equal to 0. That is number 3 equation. Number 4th equation, minus 3A plus 7B plus 6C is equal to 0. This is number 4th equation. Right? So these solve, you get A, B, C values. Right? 1, 2, 3, 4, you solve it, you will get the A, B, C values. A, B, C values. So now in this, you write as A, B, C values. Left side you completed. Shall I go for next solvation part? Write the augmented matrix, easy to solve, right? Consider augmented matrix. Augmented matrix. What is augmented matrix here? A such that 0 bar. A such that 0 bar. That implies A such that 0 bar is equal to, write these equations now. What are the 1, 2, minus 1, minus 3, minus 4, 5, 0, 7. Then next minus 2, minus 4, 2, 6, 0, 0, 0, 0. This is the augmented matrix. Once you get the augmented matrix, now you want required reduce the matrices. Apply for the row operations. Apply row operations. Row operations. So apply the row operations here. R2 first in the position of 2. You want 0, it becomes a 0. How do you get that? R2 is here 2. And multiply my 2 into R1. Then next here minus 1 is there R3. R3 is here minus 1 and plus R1. Minus 1 plus 1, 0. And minus 3 is here R4. R4 is minus 3, multiply with 3 here. That is plus 3R1. Plus 3R1. So now similarly you write matrix, no, first row no change, 0, second row 0 here. Why? Because R2 minus 2 R1 and next R2 here 5, 2 into R1 minus into minus plus 2 into 4 8, 8 plus 5 13. Then next R2 is here minus 4, minus into minus plus 2 into 2 4, minus 4 plus 4 0, right? Then next R2 here is 0. Then next minus 1 plus 1 0, third row, then R3 0 minus 4 only, R3 is 2, 2 minus 2 0, then here 0 minus 0 plus 0. Then next R4 is minus 3 plus 3 0, then R4 is here 7 here multiply with 3 into R1, minus 4 into 3 minus 12 plus 7 minus 5, right? Then next R4 is here 6, then 3 into R1, that is minus 6 plus 6 minus 6 0, then remaining is 0. That's it. Is it clear? So after that you want, see, observe this. This is minus 5, this is minus 4, 13, minus 4. First you want this, bring it to 1. Bring it to 1. Second row 13 is bring it to 1. You write divided by 13. Okay. So now second operation I will write R2 by 13. Why? Because 13 divided by 13. Because if you have simplification is very easy. Right. You are going to simplification is easy. So now similarly write 1 minus 4 minus 2 0 0 1 0 0 0 minus 4 0 0 0 minus 5 0 0. That's it. Right. So after that 1 becomes these zeros. These zeros. So you want that zeros means, how do you get that? Can you tell me the? Again row operations using by R1 first, minus 4 is there, then plus 4 means R2, just 4 into R2, right? Clear? Then next here minus 4 same, R3 same, R3 plus 4 into R2, then next R4 is what you write? R4 is minus 5. Here how much multiply? 5 into R2. So then similar, you write 1, 0. Again 4 into R2 is 0. Then R1 is here minus 2. Same 0. Then same 0, 1, 0, 0. Then next 0, 0, 0, 0. 0, 0, 0, 0. Is it clear? So now here, now write the equations now. This is A, this is B, this is C, this is 0, right? So now multiply with A minus 2C equal to 0, first equation, right? Second equation, B equal to 0, second equation. B multiply na? B equal to 0. Then remaining is solve. Now what do you write now? A equal to 2C. A equal to 2C. Now A equal to how many solutions? Infinite solutions. If you put C equal to value, infinite solutions you will get. If you want C, how many solutions? Infinite solutions, right? So infinite solutions you will get. It is not a linear independent. Is it right? Why? Because one scalar is not equal to 0. Is it right? One scalar is equal to not equal to 0. If you keep A, C equal to 0, A equal to 0. If A is equal to 0, C equal to 0. This is a possibility. But it is not possibility of C equal to 0 and A equal to 0 because of it is non-zero values. So infinite solutions. Write down. Write down here. Write down here. Clearly, there are 3 pivot positions there are 3 pivot positions. 3 are there? 2 only. 2 pivot positions. And hence the system has 2 variables. 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 System has 2 variables. Then H is spanned by the set. H is spanned by the set. V1 bar is equal to 1, 2, minus 1, minus 3. 1, 2, minus 1, minus 3, comma, V2 bar is equal to minus 4, 5, 0, 7, and V3 bar is equal to minus 2, minus 4, 2, 6. Further, V3 bar is equal to minus 2 into V1. Minus 2 into V1. If you take a minus 2 common, please observe this. That is, I'll write, that is V3 bar is equal to minus 2 into V1 bar. That implies, see, observe this, 1, 2, minus 1, minus 3 is equal to, here take minus 2 common into V1. Minus 2 into, V3 is how much? That is minus 2, minus 4, and 2 and 6. And minus 2 into V1 is 1. Here take a 1 common, 1. Then here 2, then 1, minus 1, and here 3, minus 3. Minus 3. Please observe this. V3 bar is equal to third vector. Minus 2, minus 4, 2, 6. If you take a common minus 2, take a common from minus 2 here, that is 1. Then next here 2. Then here, see, observe this. Minus 2 into minus 1, 2. Minus 2 into minus 3, 6. But what is this vector? V1 bar vector. So we can write as here, that is equal to minus 2 into V1 bar. That is the reason. Okay. That is a minus 2 into V1 bar. Hence, the set V1 bar comma V2 bar also span H by spanning set theorem. V1 bar comma V2 bar also span H by spanning set theorem. Now V1 bar and V2 bar are not multiple of each other. Hence set of V1 bar comma V2 bar is linearly independent. Therefore set of 1, 2, minus 1, minus 3, comma, minus 4, 5, 0, 7, 0, 7 or form a basis or form a basis or form a basis for H or form a basis for H. Hence dimension of H is equal to dimension of H is equal to 2. Dimension of H is equal to 2. So what do you say here? The spanning set theorem says if you two vectors are here, three vectors are not satisfied. If the two vectors are linear span, those two vectors are linear independent. V1 and V2 bar is not multiple of each other, therefore it is linearly independent. This is only linear dependent vector. Because of linearly dependent, why? It is V3 bar is a depending on V1 bar. Depending on V1 bar. That's why V3 bar is discarded by spanning set theorem. Discarded. By spanning set theorem says out of three vectors, at least one more vector is discarded. One more vector is discarded from out of three. That is still spannage. Still spannage. That is the by spanning set theorem says V3 bar is a depending on V1 vector. That's why V3 bar is a discarded from the set of vectors. So the remaining vectors are linearly independent. What are the remaining vectors? V1 bar and V2 bar are the remaining vectors. Those remaining vectors are linear independent. Those two vectors are linear span of the vectors. So once both are satisfied, it is form a basis. Once it is a form a basis, therefore it is a dimension of H is equal to 2. So this is the reason. So because of here the three vectors are not defined a linear independent. So one of the vector, why it is so? It is a one of the vector is depending of other. Depending of other. So that means V3 bar is a scalar multiple of the other vector. So that's why it is not a linear independent vector. So once it is a discarded from the set V1 and V2 and V3 bar, so therefore remaining sets are 2. What is the meaning of that? Span. Still you have set of V1 bar, comma V2 bar, comma V3 bar. Subset are equal span set of V1 bar, comma V2 bar. This is the spanning set theorem says. Right? Span set of V1 bar, V2 bar and V3 bar containing of span V1 and V2. This is a span, this is also span. But this is not a linear independent, this is a linear independent. Right? So this is the two regarding in this. This is a not linear independent means, what is the meaning of that? One vector is depending on the other vector. So that means that is called as linearly dependent vector. V3 is dependent vector. That's why this set is not satisfied the linear independent. The remaining the two vectors are linear span and also linear independent. So therefore it is called as a basis. So those bases you write here. That is dimension of H is equal to 2. Right? So this is the regarding of today's class, dimension of how to find the dimension of set. Okay? Right. Thank you.